This is systems of equations, but with a different method of solving. So we can solve these through graphing or elimination. We can also solve these through substitution, which it works every single time. So what I mean by substitution is I'm just trying to solve one of these for one variable. These are both already solved for y, and then plug it back in to the other equation. So what I mean by that is if y equals x minus 3, I can just substitute that back in for the y up here, which means that this is going to be x minus 3 equals this, 4x minus 9. Okay, so to solve this, I can start by subtracting x from both sides. I'm going to get negative 3 equals 3x minus 9. To get rid of this, I can add 9 to both sides. Plus 9 gives me 6 equals 3x. And then the last step is just divide out this 3. You're going to get 2. All right, so that's the first half here. I've got the x. Now I just need to get the y. I know the x is 2, so all I'm going to do is just plug this back in to the other equation. So y equals x minus 3. Instead of x, I'm going to say 2, because I'm substituting the 2 for x. Y equals 2 minus 3. And then if I just subtract these 2 minus 3, y would have to equal negative 1. So that's really going to be my solution here. The x is 2, the y is negative 1. That's pretty much it. And I can solve this without even graphing it or putting it into y equals mx plus b. This one is it's a little more usable just because it works for any type of problem, any linear equation. All right, here's one that's a little trickier. So the first equation is already solved for y. So I definitely want to take this and plug it into the y here. We just always want to do things the simplest way possible in math. It's already complicated enough. All right, so what this is going to give me is negative 15x plus 3. And then instead of the y, I'm writing this whole equation. 5x plus 2. And that's going to equal 6. So what I've done is I've just substituted this equation for y in for y on the second equation. And now I can just solve this like I normally do. So let's bring this down, negative 15x. We're going to distribute the 3. 3 times 5 is 15. X, 3 times 2 is 6. And look at what's happening here. The negative 15x and the 15x, these are going to cancel out. So I really just have 6 equals 6 as my solution here. So really I can make x any number, I can make y any number, and 6 is always going to equal 6. So this, we call this all real numbers. All real numbers. Or the way to write this mathematically is it's like a big R with an extra line through it, just like that. And this just means all real numbers, just so we don't have to write out the whole phrase. So mathematicians are lazy. Yes, this is true.